Okay, we're in section 35 of the notes. This is the assignments, or the material in 2x2 linear systems. What we're doing here is we're solving linear systems by two different methods. We're going to be given two equations, they're lines. We're going to graph those lines and find a point of intersection. The other method we used was called substitution, which I actually found better than graphing because I'm just not good at graphing. So we went through some examples. Certainly a good visual is nice to have. And the visuals that we've given you, again, there's videos over here if you need to watch that again. The videos are pretty informative if they help you. If they don't watch the videos. Do what works for you. Here we do is we graph a line out, we look at it. And again, sometimes, looking at it, you can get a solution by looking at it. Sometimes you can't, by the way. But I'm going to say this looks like x is -2, y is 3. Again, two lines have been graphed. We're looking for a point of intersection. That's a visual process that we've gone through with you. We've also done substitution. What does that require? You take one of the equations, solve for either x or y, and substitute the other equation. We went through those examples with you, right? We did a bunch of examples in class together, as either at the whiteboard or at the blackboard. We went through those examples, and hopefully you understood those examples that I presented to you. The point at which you're now saying, gee, I wonder if I can do this on my own, and you got to start trying. So we went through some problems, and then you get to the section where you're going to try on your own. And that's where I'm going to switch to the whiteboard. All right. Oh, by the way, there was also some word problems we do. They're going to be very similar in content when we start doing the homework. The deal is this now. The expectation is you've listened to what we've done in class. You paid attention. You've studied the material. You look back over the examples, and you're ready to try on your own now. Trying is going to be a characteristic of being successful. You want to start to try things. I'm going to go to a different screen now. I'll get my whiteboard out. Just give me 1 second. Again, we're writing problems that work nicely. However, you may not agree with that. You may look at this and say, no, these things are not working nice for me. They should be. We're not writing problems that are not working for you. All right. They illustrate the points that we're teaching at the school. So let me see what we're going to do over here. Let me get another share with you. Okay, so you're looking at my whiteboard now. And where are we? We're in section 35 now. And we're doing the homework. The homework is basically a repetition of what you've done in class with slightly different problems, not substantially so. So number one, what they ask me is they say, is the ordered pair, let me write this down for you. Well, that's simple because x equals y is equal to 1. So they're saying, is the ordered pair a solution to this system of linear equations? So you have 2x minus 5y equals -3. And you have x plus 5y is equal to 6. What you need to do is plug it into both equations and see if it makes sense. The answer is either going to be yes, it is, or no, it's not. It's going to be 2 minus 5. I'm just plugging in x and y as 1, is -3. And this certainly makes sense. The next one is 1 plus 5 is equal to 6. Certainly both make sense. If they both make sense, the answer is a resounding yes. All right. So again, look at the key and make sure you're staring at that. Let's go to number 2. Again, we want you to read these instructions and see if you can understand what they've given you. So as they solve by graphing, well, they give me a system, and the system is x plus 2y is equal to -1, and the other equation, these are lines, -2y is equal to 3. Well, what I would recommend you do is graph one line at a time. So for example, you're going to graph this line over here. You need to make a table of values up for this. We're going to graph one line at a time. Now, what would I'd probably pick, y to be 0. I see if it's easy. So if y is 0, what you get? You get -1 for x. That's not so bad. Here's the deal. If you can find one easy point, there's an infinite number of easy points to look at. What I mean by easy integer. Now I'm going to try x to be 1. And if I did that, the y would have to be -1. All right, I'm going to graph that out now for you. And this is the first line. It's going to be minus 1, 0. And then 1 minus 1. Okay, that's done. All right, I'm going to do the other line now. This one over here. And I'll put this table over here. And I'd probably choose y to be 0 again. And then what if I get 3, right? And let's see what other good, easy value I'd pick over there. I guess x to be 1 doesn't look too bad. And if I did that, the y would have to be minus 1. Let me plot those out for you. So 3, 0. All right, and then 1 minus 1. Let me draw that in for you. Now, did those two lines intersect? And they appear to intersect at this point over here, which is 1 minus 1. So I'm going to put my answer down now. And what's the answer going to be? I believe 1 minus 1. All right, look at the answer key, and you are staring at that, and you should feel good about that. You want to move forward. Let's do number 3. Again, the expectation here is you've done a certain amount of study and that you've worked these problems already. All right, you understand what we're doing, and you're following along pretty quickly. This one's solved by graphing. It's a system of linear equations. X plus 5 equals 1. And the second equation is y minus 2 equals 3. Well, you know what? My experience from the past of graphing lines, I'm getting better at this. I'm just going to just simply write down x equals minus 4 and y is equal to 5. And I'm going to graph those two lines out for you. And I'll graph them one at a time. I'll graph this one first. X is minus 4. And then I'll graph this one out. And that's y equals 5. And that looks like this over here. Did those two things intersect? Yeah, they did. Where'd they intersect? Right over here. Now let me write this over here for you. This is the line x equals minus 4. And this is the line y equals 5. Where they intersect? At a point. And what is that point? The point's pretty simple. It's going to be where x is minus 4 and y is 5. Again, I said solve by graphing, we've done that, and we've got our point of intersection, which is minus 4, 5. Let's go to number 4. And number 4 says solve by graphing. So you get 2x minus 3y is equal to 5, and then you get x plus y is equal to 0. Well, the second equation looks easier for me. I'll put this one over here to table values down. So I'm going to, basically say, table of values would be pretty simple for this guy over here. X, y, I'd say 0, 0. That's pretty simple. And then I would say 1 minus 1. All right, I'm going to put a graph down for that point, those 2 points there. 0, 0. And then 1 minus 1. Let me draw my line through that. Okay, let's do the other line. A little more complicated. I think I can do it. And let's go through it. Let's take a look. I would say probably, I'm looking at 2 and 3, and I certainly come up to a 5 at some point. So x is 1, and y would have to be minus 1. That seems to be okay. All right, let's do another one. And I need 2 points, right? So let's take a look. And I'm going to say y is 1, right? Let's see, x would be 4 then, right? Let's make sure of that. 2 times 4 is 8. 8 minus 3, yeah, it looks pretty good. Let's plot those points down. So first point is 1 minus 1. It's right here. The other point was 4, 1. Let's draw a line through. And we found a point of intersection. Pretty simple. That point of intersection appeared to be 1 minus 1. Again, look at the answer key, and you're staring at that. All right, so we're off the graphing part. And I'm kind of thankful for that because I didn't like graphing anyway. I'm going to put number 5 down. If I say this by substitution, write this down. It's 8x minus 5y is equal to 35. Y equals 4x minus 19. Well, what you need to do is select one of these equations, either one, and solve for either x or y. Well, what do I notice immediately? This equation here is already solved for y. It says y equals that 4x minus 19. So what I'm going to do is I'm going to take this thing here, which is y, and I'm going to substitute it up here and see what we get. 8x minus 5y. Well, I believe y is 4x minus 19 equals 35. 8x minus 20x plus, let's see, that's going to give us 50 and 45, which is 95, equals 35. Let's keep going. Minus 12x, sorry about that, minus 12x. I'm going to subtract 95 from both sides, and you would get minus 60. So what's x? X is going to be equal to 5 then, right? Okay, someone says, well, what do you need to do now? You need to take that 5 and substitute it somewhere. I'm going to say where I would like to substitute it is right here. And what would you get? Well, if you did that, you would get y is 4 times 5, which is 20, minus 19. And what does that give you? 1. So I believe my answer is x is 5 and the y is 1. I could have made a mistake. Of course, if this was an exam question, I would check it. And I check in the original. So I believe x is 5. That means I'm at 40 minus 5 is 35. That works. And let's put the second one down. I believe y is 1. And I believe x is 5. That would be 20 minus 19. And that also works. When you're doing homework, though, please look at the answer keys to make sure you're staring at those answers that are provided to you, which is 5, 1. Let's go to number 6. This is a relatively simple set of problems. We're hoping you see it as a simple set. Solve by substitution. Let's write this down. You get 2x minus 3y is equal to 5, and x plus y is equal to 0. Boy, these look like similar questions, don't they? Well, I got to solve one of those equations for either x or y. Well, I'm going to take the second equation, and I'm going to solve for y. And what would that be? Y equals minus x. Then I'm going to take this, which is what y is, and pop it in up here. And what do you get? Let's put that down. 2x minus 3. Well, it's y. What do I believe y is? Minus x equals 5. 2x plus 3x is equal to 5. 5x is equal to 5. X is equal to 1. Now what do I do? Plug it in somewhere. Now where's the easiest guy to plug it in? And again, I want to point this out to you. It's pretty easy over here. Plug it in there. What would y be? The opposite of x. I'll write that down for you. So y would be the opposite of x, which would be minus 1. What's the ordered pair? 1 comma minus 1. Look at the answer key, and you're certainly staring at that. You could also check that. Well, let's do number 7. It's a word problem. I want to point out it's not a difficult word problem, but again, some students have trouble with this because the reading of it, it becomes difficult when they're reading through these things. They don't understand what's being asked of them. So it says a rowing team rowing with the current travels 36 kilometers in 3 hours. So I'm going to say with current. They want 36 kilometers in 3 hours. Well, you know, rate times time is 36, right? So let me write that down for you. Rate times time is 36. So let's see, you know, rate is, I don't know what rate is, right? But I know time is 3. So rate times 3 is 36. So the rate has to be 12. Now 12 what? Kilometers per hour. Let me get my eraser out, and I'll erase this stuff over here, okay? All right. I'm not saying that's your question. I'm just saying I read it. It says rowing against current. I'll write this over here, against the current. Well, I'm just going to put this as D1, R1, T1. That's with current. Against current, I'll put down D2, R2, T2. So it says running against the current, the team rode 12 kilometers in the same amount of time. How much time? 3 hours then, right? Well, I'm getting pretty good at this. I think 3 times 4, right? 4 kilometers per hour. 3 times 4 is 12, right? So someone said, I wonder what their question is. Well, I haven't read that yet. It says find the rate of the rowing team in calm water. So I don't know what that is. I'll put X down. This is rate in calm water. And that's of the rowing team, by the way. That's no current. And the rate of the current. Y is the rate of current. Well, I'm going to say the rate in calm water plus the rate of the current would be with current. And what's that rate going to be? 12. It's right over here. Now, when you're going against the current, it's going to be the rate of the boat in calm water, but the current is taking away from it. So minus y would be equal to 4. All right. Now let's see if we can solve that. And how would I recommend doing that? Taking one of these equations and solving it for either x or y. Well, I'm going to say the second equation looks like a solve for y would be x minus 4 is equal to y. I'm going to take this, plug it in up here, and I'll tell you what I get. I get x plus y. Well, I believe y is x minus 4 is equal to 12. All right, let's keep going. This would give me 2x minus 4 is equal to 12. 2x is equal to 16, or x is equal to 8. So I'm going to say, I know the rate of the boat in calm water is 8 kilometers per hour. Now, what's the rate of the current? Well, I want to point out to you, I'm looking at this over here. If x is 8, 8 minus 4 would be 4. So this is going to be 4 kilometers per hour. Look at the answer key and make sure you're staring at that. And you do see the 8 kilometers per hour and 4 kilometers per hour. All right, I'm going to switch screens on you. And I just want to briefly go through that Sage Code business with you. Again, if you have the notes on your computer, click on this little red link over here. We just completed problem number 7. Click on this over here. It's going to open up a web browser if your machine is properly configured. Of course, when that web browser opens, it's going to bring you to this website, sagemath.org. And what you're going to do is, the easiest thing to do is just use the CoCalc. That's right over here. It's an instant Sage worksheet. All right. So let's click on that. CoCalc's going to launch. Again, you're getting a little introduction to how to program. Click on the CoCalc. I'm going to start a project. And again, I want to start a new project. We've been doing this for some time now. It's starting up. It takes time because we're using other people's resources. A new sheet. What kind of sheet do I want? I want a Sage worksheet. And then I'm going to start typing the commands in that I'm seeing. And it's reset. Shift return. And then I'm going to say X is a variable. We've done this before. What does it want me to do now? Plot, P-L-O-T. You know what? I did type these in before. I'm just going to do a copy paste. And I don't mind you doing that either. I'm still going to read it to you. If you want me to plot 2 things, -3 minus x and x plus 5. These are both lines where the scale is going to be, the x is going to be between -10 and 10, and the y is be between -10 and 10. Let's see what happens. So I want to point out they did that. They actually graphed the 2 lines out. One is in green, one is in blue. And the hope here is that you can look at this over here and you can determine a point of intersection. Well, looking at that, it looks like the x would be -4, and it looks like the y would be 1. All right. All right. Let's see if there's any other code. Gee, there's no other code. They just graph things out. This is good news. I can do that. And you can do that too. Graph out 2 lines on the same axis. All right. Let me just go back over the code again. We reset, we defined a variable, and we graphed out 2 lines. And those 2 lines intersected at a point. All right. That's it. Thank you.